Section 4A, using the Pythagorean theorem to solve right triangles. We're going to start with number 2. And since we have a right triangle, we're allowed to use the Pythagorean theorem. And the Pythagorean theorem is the theorem that states that if I take the two legs of a right triangle, and the two legs are the two sides that make the right angle, so we'll call that A and B, and the hypotenuse, which is the side opposite the right angle, and usually is the longest side of the triangle, is side C. And the Pythagorean theorem states that if you take the two legs, square the length of each leg and add them together, that you will get the square of the hypotenuse, or the third side. So we can use that formula. Here we have two legs and a hypotenuse. And again, the two legs are the sides that make the right angle. So 14 squared plus x squared equals 15 squared, and that's a Pythagorean theorem. If we square 14 and square 15, we get 196 and 225. To solve this, we would have to subtract the 196 from both sides, which leaves us with x squared equal to 29. And to undo a square, we square root, and that cancels our square, so we're left with just x. And this one says leave the answer in simplest radical form, and 29 is prime. So that's as good as it gets. The other type of question that this section looks at is find the area of each triangle. Now, I'm going to challenge you to work on this on your own, and we'll talk about that in class as well. But here you have a triangle that we're trying to find the area of. Right there, that big one. And what we need to do is we need to acknowledge that there are two smaller triangles here. This one and this one. Both are right triangles. Both have two sides known and one side unknown. So we can use the Pythagorean theorem to find this piece and this piece. Once we know the whole piece, we can use the formula, which is 1/2 the base times the height. And that's all I'm going to say about this one, but it's something that's a good application question that involves a little more thought than just doing the Pythagorean theorem once. So we'll try that in class.